So we welcome everybody from all over the world to come to this place, to travel around Xinjiang, because Xinjiang is a really wonderful place to travel. And we hope you can come here to discover the mystery and beauty in this part of northwest China.
Thanks a lot, Wendy. I know you're busy with broadcasting. We'll let you go, but thanks a lot, and thanks for all the support from Xinjiang Television.
Thank you.
Let's cut to the solar eclipse again on the telescope. You see the sun.
Observe the sun before totality. At totality, we'll remove the filter, and then we'll be able to see all of the lovely corona. So this will actually zoom out, so we see a wide field, and we'll see the inner and outer coronal streams.
Wow! So that's going to give us our human eye view of it.
Exactly.
Now, how about and let's take a look at the view through that telescope. So what sort of things will we see on this?
This, we're seeing the moon cover the sun. We see the photosphere. This is basically it's the surface of the sun. If we had some active regions or sunspots, we might see some of those, but unfortunately today we're not going to see those.
Okay, and there's another telescope here, coupled to this one. What does this one do? It has this gorgeous red color in the front.
This is a telescope with a hydrogen alpha filter, which is a very narrow band interference filter which rejects all of the light, again for safety, but allows a very small portion of the spectrum in the red part of the spectrum. And in that objects coming off of the limb, or perhaps on the disk, we'll see plage, brighter areas, or even filaments, darker areas. But again, today we don't see those.
Let's take a look through that one and see. So I believe this one shows the entire disk of the sun.
That's correct.
And we were seeing some of those prominences up there around 11 o'clock in this image. So we'll see some of those later.
We hope.
And okay, well that's
it's a little bit longer focal length, so we see it more as a telephoto lens, and so we'll see detail a little more close and personal. This also is safely filtered until totality. At this point, we'll see the same things as we see in the other telescope with the white light filter, the photosphere. But when we remove the filter at totality, we should have very nice views of the prominence.
Let's take a look at the view through that telescope. And I guess we're seeing a much enlarged portion, just one portion of the sun with the moon moving across it. Okay. So one last large telescope over here. So this is a beauty. It's huge. It also has that gorgeous red color on the front. What does this one do?
This is another hydrogen alpha telescope, but a longer focal length. So much like a telephoto lens, we'll really see up close and personal views of the prominence. And unfortunately, while at totality, we won't be able to see the prominence through this filter. With the white light, we'll be able to do that. We can also see as with the smaller telescope, the chronospheric network details on the disk. We don't have a lot of those features to show you today, but we can try.
Let's take a look through this telescope. And I understand that you can actually control our view. So you have this device you're holding up to show, and that device allows you to point to different portions of the sun.
That's right. We can move the telescope around and show you different features.
Let's do it. Bill's looking into his monitor, so he can actually, there's a camera on the end of each of these telescopes, and it's feeding into his monitor, so he can now control the telescope by watching. Now it's actually dimming down here.
Unfortunately, I can't control the clouds with this.
Yeah, a little tiny bit of cloud just drifted in, so it's getting very exciting here with between the clouds blocking the sun and the moon blocking the sun. Well, thank you very much. We'll look forward to seeing images from all these telescopes. So let's just take one image from one of the telescopes right now and see how we're doing.
My light reading meter isn't very accurate, and it's got about 700 foot candles with the cloud going in front of the sun. We think they're going to clear though, and we're going to have a good image of the total solar eclipse when we get back to that. This meter also measures color, and when I was at the last eclipse in Turkey 2 years ago, I really found the color change very interesting as we got close to totality. We kind of think of maybe totality like being a sunset when the sun gets all red, but here, of course, the sun is getting covered when it's high up in the sky. It's more like a dark cloud passing over in front of the sun, and yet there's also an interesting color shift. So I'm going to see if I can measure some of the color shifting going on. And right now, already the sun, which is normally at about 6,000 degrees, the way we measure color, it's actually come down to about 5,300 degrees at this time. And might be a good time, since we're about 15 minutes from totality, to give the viewers a viewer's guide to the eclipse. What are they going to see when they see this wonderful event?
So as the moon moves to cover the sun, as it's doing now, and look at that beautiful arc there, even with a few clouds in it, the photosphere, the bright part of the sun that we normally see, like when you're watching the sun safely at sunset or looking through our safe solar viewing glasses, will be blocked by the moon. But the thing is, the moon has a rough edge, mountains and valleys, and some of that photosphere will shine through the valleys of the moon, and that makes a phenomena called Bailey's beads. So we have an image that shows that. So if I can show you the image. So there it is. The moon has almost blocked the sun in this image, and the light shining through the valleys on the moon makes a wonderful ring of beads. Now, also, accompanying Bailey's beads, when they finally go out, there's a red ring around the moon. And that red ring is a part of the solar atmosphere that we can never see when the photosphere is visible. It's called the chromosphere. And that chromosphere is the part of the sun. It's red and hot pink. It's a little bit dimmer and cooler than the photosphere. And the eclipse allows us to see that. Now, we can actually see in this image the peaks and valleys on the moon. This is an image of the edge of the moon, and it shows you that natural roughness. And even if we hadn't sent spacecraft to the moon, we could see that natural roughness by the Bailey's beads in the total solar eclipse. Well, finally, that chromosphere will be blocked, and then my favorite part of the eclipse will happen. The corona, this hot million-degree Kelvin white gas, will reach out as white lines far out from the sun, and it's gorgeous. Also, the sun will go out. My eyes will adapt. It'll be night. We'll see the planet near the sun will be Mercury. A little bit further will be Venus. And just beyond that, the star Regulus. So we'll have night here for 2 minutes. Then at the end of the night, everything will be reversed. The chromosphere will appear on the other side of the sun. Bailey's beads will appear. And then we'll be marching back to more regular view.
This is a spectacular image we're getting now from our live cameras of the eclipse. You can see the clouds are moving in. We hope they'll move away before we get to totality. It might be a good idea to start to talk a little bit about some of the solar physics that's going on in the sun.
So we have with us today Dr. Eric Christian, who's a NASA scientist, a helio region. Let's show some images of those for you.
So here's an image from the NASA TRACE spacecraft of an active region. And what you're seeing is actually the hot gas tracing out the magnetic field of the sun. If you've ever done the experiment with the bar magnet, where you put iron filings on it, you'll see that the iron filings actually trace out the magnetic trace again, where you can see the gas flowing along these magnetic field lines and glowing. Pretty impressive.